Hello, everyone, and welcome to the episode 31 of the Office Hours podcast. In today's episode, we talked about what your first programming language might be, how your programming language choice might affect your future progress as a software developer, and how you might want to plan your first steps on this path. We also talked about some languages that are popular currently, differences between compiled and interpreted languages, their merits and drawbacks. Using the example of Rust, Ruby, Python, Java, and JavaScript, we've chatted about the different spectrums these languages occupy and how these things affect your selection of a tool for your job. Then the conversation went into fundamental differences between compilers and interpreters and touched on subjects of JITs, AOTs, and what constitutes a compiler in a more pedantic sense. So we hope you enjoy this conversation. Thank you. Hello, everyone, and welcome to the episode 31 of the Office Hours podcast. We are happy to have Mo with us today, and let's get on with it. How's it going, Mo?
It's going good. And you?
Doing well. We actually booked some vacation in a couple of months, so I'm pretty excited about that.
That vacation is good. Where you going?
Mexico,
Oh,
yeah.
fantastic.
So just it's gonna be very you know, easy existence. It's an all-inclusive spot, so just chilling at the beach, eating, sleeping, reading, and enjoying myself. That's the plan, at least for me.
This is good. This is good. Mexico is always a good place to go because, I mean, there's a lot of people, there's a lot of nice places to visit, and it's sunny.
Yeah,
So
it's gonna be like
it's
30 degrees or something like that.
yeah, Mexico is good. I'm
Mm-hmm.
happy for you,
Yeah,
basically.
thank you, thank you.
Yeah. Well, today I wanted to talk to you about there is a it's a popular question on the tech Twitter, and this question is, what is the best programming language to learn in 2024? And to be honest, there there is always a revision of this question. 2023, 2022, 2020, blah blah blah. 2024 is where we are now. So I don't like this question. Personally, it's a question that really triggers me a little bit because it kind of makes everybody think like there is one language that is better than one, or like there is one. But recently, I came across this question again, and I started thinking about it. Like, I guess people who are looking to start programming, or people who are looking to learn programming for certain reasons, different reasons, might want to know some things about this. And since our podcast is to help people like this, who are looking to get into the industry, I'm curious to, I decided to ask you, what do you think? What would be your counsel to someone asking you what's the best programming language to learn in 2024?
Yeah, very good question and a very, excuse me, very fair point that, saying what is the best language to learn does kind of pose this. There is just one language out there that's good for everything. And, we talked a little bit about it in a previous episode when we were talking about like the tools and pick appropriate tools for the job, right?
Mm-hmm. Mm-hmm.
And I guess a couple of years back, my answer by default would probably be JavaScript just because of how available it is and how you don't really need that much to start. But now I I'm kind of revising it a little bit because, you know, I um I listened to this opinion, or rather, I heard this opinion recently that, if you go into web dev, uh, you are unlikely to ever, progress beyond web dev. It wasn't formulated in that way, but I kind of broadly agree with that sentiment. Like web dev is such its own thing that once you're very comfortable in it, it would be hard to switch to something else, I think. And it's it's it does not allow for like the full expansion of one's potential, I think. It's like a very limited domain. And so like if you learn JavaScript, then you know the path to web dev is basically the one path that you kind of have in front of you with this language. And once you're in that tar pit, you're never going to leave. I mean, and I looked at my own experiences with it. And to me personally, that is kind of true. We talked about it last episode, or the one prior to, where I started with PHP. So, well, not really. I mean, like I started experimenting with compilers that produce Windows programs for your desktop, right? So that was predating the internet or widely available internet for me. But I did not know what I was doing. I was just sort of poking around, trying to figure it out on my own. But then I happened to go into web dev sort of by accident and sort of stayed there for 20 years. And now whenever I see in, developments in other areas, I usually look at it as like, wow, this is pretty cool, but I don't know if I can acquire all the necessary skills in a short enough time. And like, I can't necessarily switch to those industries because I don't have enough experience, and acquiring that experience now is going to be harder than 20 years ago. It's not harder because it's like, I think 20 years ago there was far less availability of excuse me, of documentation on things, so it would have been more difficult then. But then your brain soaks up information much quicker when you're 20 compared to when you're 40. So on that aspect, for me, it would be difficult to like learn some completely different language from the web ecosystem. And so if you want to go into IT for, how do I formulate it? Like, there's obviously a demand for web dev. It's like, you learn JavaScript, TypeScript, you learn React, you learn some frameworks, and you can probably find a job these days. It's very in demand. But if you want to progress further than that, if you want to become more advanced, going into JavaScript would not be ideal because it would be very difficult to get out of it later on, I think. It might not be true. I mean, there's obviously people who can learn things and learn other languages, learn compile languages, learn like Rust or C or C++ or what have you, and make that transition into more, I was going to say more serious development. It's not like the web development is not serious, right? But I think that on some levels it's more trivial compared to the rest of it. We're just battling the quirks of our environments and the complexities that we create for ourselves. Like most web developers aren't solving any particularly interesting engineering challenges. Like, they build products, which is necessary, but you kind of plateau eventually in this area. So in terms of what is the good language to learn as a beginner, I guess the question is it are you learning the language to learn the fundamentals and just understanding in general how principles of computing work? That is still a pretty good. It's like, if you start with something that is easy to learn, you might again find the next thing that much harder. Because it's like, well, if I start with Ruby, for instance, Ruby is a very easy language to learn. It has its quirks, but not nearly as many as JavaScript, for instance. And it takes care of so much for you that when you start like looking at Rust or C or C++, and it's like, ooh, memory management, oh, all of the way more advanced things, you'd be like, oh man, that wall is much harder to scale. But if you start with something too crazy, like Rust, for instance, not only you have to understand the computing fundamentals, but you also have to understand everything that the compiler wants from you. So that could be a little bit insurmountable, and you kind of need something in the middle. So I don't even know. Maybe something like Zig, because it kind of has a little bit of both. You have this sort of C-like environment. You're producing compiled programs. You can, do all of your functions and loops and conditions and stuff. You can do I/O. You can do networking. You can do a ton of stuff. And at the same time, it does give you much lower level access to things. So you can, satisfy your curiosity there and then expand to something more sophisticated. On the other hand, the beauty of web dev is the immediacy of result. Like you see it right away. Because with a lot of like compiled programs and more of a like server-side applications where you only have your console as the means of interacting with that application, you don't have that same impact of building some site in React where it's just like, you press save in your Visual Studio Code and boom, it just appears on your screen. It's like, holy shit, you get this immediate response that can be very, very gratifying early on to kind of keep you motivated. So yeah, I don't know. It's a very, very complicated question. I think if you want to learn a programming language, in a beginning, if you go for something conventional, just pick a language. It doesn't really matter that much to understand the fundamentals. Like a function is a function is a function in pretty much any language, and a loop and a condition are going to be basically same whatever you do. And yeah, I'm like half stumped. I don't want to give another one of those, hey, there's a silver bullet language that if you learn that, it's all good. You don't need to do anything else.
So from your answer, it seems that you have this is how I understand it. It seems you have a preferred language, maybe because you work as a web developer and probably also more experience in front end because the I can tell because I don't know if there is a I think JavaScript has evolved more than web development, first of all. There is JavaScript in almost many other areas of software development or like software engineering generally. Like even in data science, we have different um, use of the JavaScript around there too. And JavaScript is really competing with Python in that industry right now. Like it really, it's even very close. So I don't know if I don't know. I don't think personally for me, I don't think and this is the reason why I don't like the question. Because I think when people try to answer questions like this, they try to box themselves in a particular niche. And like you said, it depends on what you're trying to do. And also depends on how much time you have to learn. So to me, there's a lot of factors that's involved in decisions like this. And I still don't see one language being better than the other. It's as good as human languages to me, and this is my opinion, right? Like you don't think English is better than French, or or French is better than whatever language, Spanish or something like this. Like it depends on where you are and what who you'll be speaking with generally, like your audience or stuff like
I
that.
think
So
that's a really good metaphor.
yeah, so it's really for me. I don't think, and also like I think if you spend a lot of time in like web development and you write a lot of JavaScript, like probably like for a period of time, because you write your JavaScript in React, it's still JavaScript. It's still the same functions and methods that you will write in other places. You might be using it in a different way, but I don't think it's that far-fetched. I think it's still the same kind of learning that you will still and also you mentioned like web development, like there is no a lot of problem solving, but I think there's a lot of problem maybe in the front end, but there's there's a lot of things that's going on in the back end that that still requires a lot of logic. Maybe in the front end, most of what some people do might just be to write a component and just fetch stuff from the back end and stuff like this and display your list, add a form. But these things are still kind of complicated too because they still need a lot of logical reasoning. So honestly, my own way to see it is very I don't know the exact word, but I don't think there is one language that you can box yourself.
Yeah,
I think it
yeah,
depends on how much time you have to learn and how much what exactly you intend to do and how much time you have to do what you want to do. So
yeah, yeah,
because if you pick a language like JavaScript, there is a whole lot of resources available, a lot of resources like Python. There's a lot of resources, a lot of community, a lot of people that will be available to help you if you have any issues or stuff like this, compared to picking a language like Golang, for example. Like, I think even though there might be a lot of resources available, I don't know if there's as much as JavaScript or Python or like these
yeah. Well, I
programming
mean,
languages.
there's all these indices, like programming language indices, like the Stack Overflow annual survey that they do every year. Well, annual, I said that already, but they do that survey where they ask the popularity of languages and what people want to try out and what people are currently using and what they want to not use it as much anymore. So, and I think the other thought that I had during this was that as a beginner, your biggest problem is that you just don't know what you don't know. So you're just gonna be tripping up, like regardless of what language you pick, you're gonna be tripping up over all sorts of stuff. And if you want to build something in particular without experience, it's like me going and buying things for, I don't know, like construction supplies. It's kind of exactly the same thing. When I was doing this project on my garage, I had to go to the store like 25 times just because, like, oh, I actually need this. Oh, I also need that. Oh, I also need this. So every time I figure it out, I was like, okay, well, here I am driving back to Home Depot again because I just did not know that it was also necessary, right? So when you're
Mhm.
starting any new endeavor, you just don't know what you don't know, and every time you find out, you have to kind of adjust. So start with something, see how far that takes you, and you're gonna trip over a bunch of stuff, and you're gonna step on a bunch of rakes that'll like fly and
Yeah.
smack you right in the face. And then you'll have a better understanding of where you want to go. Because programming and software development, it's such a massive domain. It's huge. There's just so much stuff to do. And people have their proclivities. You might not like front end. Some people just don't enjoy doing front end. And I mean, I don't blame them. It's kind of a shit show. But uh, I
Yeah.
the thing is, so 20 years ago, there was definitely more focus on um, high expertise developers. And these days, there's more focus on like wide range expertise. And by definition, like if you have super narrow domain, then you're going to be very advanced in it. But if you're very broad, you cannot be as advanced in all of the things. And so right now, you have to sort of explore the space and see what grabs you, and then figure it out from there. So there
Yeah.
isn't there isn't a silver bullet language. All of them have their own annoying parts. Um, and yeah, in terms of resources, that's a really good point. Like resources and community, obviously the most popular languages are going to have the biggest amount of resources and community. So I can't necessarily say always that the community is always going to be helpful and they're like just always going to guide you through whatever you might be having. That's not always the case. Usually because professionals don't like really dumb questions because they already know the answers to them, right? So I'm in this TypeScript chat, which is a pretty big community, mostly Russian speaking, but occasionally we have some like people asking questions in English. And I noticed that there could be more patience for simpler questions, but at the same time, simpler questions are also like Googleable. So I guess what I'm trying to say is just trying to rely on abstract community.
Mhm.
It's out there. You can get some answers, but don't expect people to kind of hold your hand through it and just be there. It's like, no, it's not going to be like that. And if you ask too many dumb questions, you're going to get called a dummy, and that's kind
Yeah,
of it. Like, because I mean, it's still people. But I mean, there's also in-person things. Like, there's various workshops. Usually you can probably find a meetup, and if you make personal connections, it might be much easier. And yeah, obviously, like, tutorials and things. The other thing though is, I guess before, when the information was guarded more, like before you learn Microsoft Visual C++, you need to have the subscription and you need to have like access to their docs. But then you have the documentation, and it's from the source, right? So it's mostly good. But these days, there's all the people making tutorials on YouTube and doing this and doing that. And I think the overall quality, and as a beginner, you wouldn't necessarily know what is good stuff and what is not so good stuff, right? So there's those risks. Um, so yeah, I think if you're trying to learn it on your own, it's doable, but it's gonna be harder. It would be much better to, find someone to help you with it.
yeah, absolutely. And I think the reason why most times I suggest community is because I find like it is easier to do things like this, like learning stuff like this in a group. But also it depends on your personality because even me, like I don't like to learn in the community because I prefer to learn by myself because I want to make my own mistakes and if I have issues, I go on my own. But it's not. It makes it really hard because if you learn in a group, one time I think I came across this Udemy course. There was a course like that. And the guy is teaching style was to actually create a whole Discord channel, and then there was like loads of people there who were learning the same material, like the same course. So it was it made it fun in a way, like it was easy to find someone who probably might make the same mistake that you made, and you can talk about it, you can build more relationships and like stuff like this, and maybe someone within this place will probably have some information that can help you in your project or maybe getting a job or stuff like this, stuff like that. And I guess in many ways you have to figure out the community that you're being part of because it sounds like your community is community of experts. And if you go to a community of experts and you ask dumb questions, for sure you'll be called dummy. I remember one time I started I started doing like this open source stuff. Like I was going through like a project and I was looking for how to I forgot which project was that? I think maybe it was pandas. Yes. I was looking for how to um set up set up like the environment of my stuff, but at the time it was just a Docker container. It's not that complicated, but at the time I didn't know much about like Docker or how to do all of. So I remember I contacted someone on the channel to help me with it, and to tell from his answer, like he was surprised that what are you doing here if you don't know how to set? So yeah, like I could tell, but it was an experience and it was a moment for me to understand this kind of things because you have to know like the
Yeah,
community that you are being part of.
yeah,
Like
yeah.
you have to be amongst your own strengths, the people with the similar strengths, I guess. Like, but anyway, while you were talking earlier, you mentioned Rust programming language, and it's something that I've also been noticing a lot these days. I mean, it's gaining a lot of popularity. And people say it has like a lot of memory safety features, and but I've not really tried it. I'm curious, have you had some time to look into it?
I haven't really tried it myself. In terms of popularity, there's this meme about, the Rust Evangelism Strike Force. There's just so many fanboys just saying that the
Hmm.
Rust is like the best thing since sliced bread,
Hmm.
the
Yeah,
gift from gods. There's nothing above Rust, and you should only use Rust for everything.
I've seen that. I've seen that.
Which is again a bit of a I don't know if it's a hot take, but it's more of a like yeah, calm down, whatever. So I think Rust definitely has gotten a lot of popularity in recent years because it originated as like a research project from Mozilla and then kind of took on a life of its own. And I've been following it since fairly early, but because I didn't really have a project to apply it to, I couldn't really necessarily um, find the time or desire to actually start with it. See, and that's the thing that I was referring to. It's like yeah, I can build a server in Rust and it would be pretty cool, but I can just also build one with Express in like 15 minutes and not have to spend days and days and days and days tripping all over stuff. I'm just too lazy for that right now. So it's like the being in the trap of of comfort of the things you already know.
Mhm.
So I haven't had a chance to try Rust, and I understand what they're trying to do, but it also I hear a lot that it requires you to contort to match the compiler's expectations. So the compiler forces you down this very, very narrow path to be able to provide you with the guarantees that it does, right? And whenever somebody posts something about Rust and I attempt to read the code, like I vaguely get it, but not always. And the whole borrow checker syntax, because I haven't really used it, it's still a complete mystery to me. So I don't find it as expressive. And with years, to me, the understanding is that most of the time you're not writing code, you're reading code. Expressiveness of language, of a programming language, is a big deal because you want to be able to read it and understand immediately what's going on. And with Rust, it's just like, oh, what are they doing here? It's like, oh my god, like it becomes very difficult. And so maybe that's why whenever I look at it, I'm just like, screw that noise. It looks cool and it has interesting goals. It's like big idea language, and it sometimes it kind of feels like a little bit too much. But that could also be my very unqualified opinion as a mere JavaScript guy. It's like, what the hell do I know?
I mean, I hope it has like similarities to popular languages, but it's just like I've heard a lot about it. Like, oh, um, it's like you just mentioned, like it forces the compiler to like the code compiler relationship. Like you can't do certain things, get away with like most of the issues that you have in like JavaScript.
Yeah.
Like you hear like a lot of people talk a big things about it, you know. And
Yeah.
one time I was reading that um many CEOs are like trying to change their company code to those stuff like this.
That's a really
Personally, I've
bad
never even
idea.
seen I've never even seen a Rust code till
Okay.
now.
Okay.
But so I don't
Yeah.
know what it looks like. I don't know.
I mean,
So,
there's not really that much difference. Like the borrow checker syntax where you have to specify lifetimes for things, and it kind of follows this system where you have it's a trait based language from what I understand. So like instead of having classes, you just have these structs that define some data shapes, and then you can attach various trait implementations for them. uh, and I think it forces you to, like, certain things you can do in other languages trivially, and in Rust you can do them, but you have to go through this very elaborate exercise of putting everything just right. to satisfy the compiler. And if the design goals of Rust align with your goals of what you want, like memory safety and performance, because I guess the cool things with Rust is because the compiler does so much heavy lifting, all of that checking code is not, it gets eliminated. So whatever the compiler finally, like the final binary is going to be like highly optimized stuff with all of those checks removed, because you kind of made those guarantees at compile time that it's going to go a certain way. Whereas in other languages, like they have to embed all of this checking code into the runtime and like throw exceptions. I mean, Rust also throws exceptions, obviously, but the whole point is like a lot of these abstractions are like what's called zero cost abstractions, because they are eliminated from the final result, and the code just does the thing without like actually having to go through all of the layers, because the layers are there for compiler to establish that everything's peachy, and then it's just like gets rid of it all. But if Rust's goals are not your goals, it's like trying to win a Formula One by driving a tractor. It's like, yeah, they both have motors and wheels and they both are steerable, but they're built for different purposes, and you're trying to use it where it doesn't really work, or trying to, plow a field with a Formula One car,
Yeah.
It's like, it's very powerful, but it's not going to help you there in the slightest, because it's just different task. So again, tools have to be appropriate for the task.
Yeah.
And I like, people build a lot of system software with it, and I think now there's also it's kind of everywhere, because there's libraries for all sorts of things. You can build backend code, you can even build front end code, because they added something very resembling JSX to Rust, so it can actually generate component code. You write it in Rust, and then it gets HTML on the other end, which is pretty cool. I mean, there's a lot of cool things that are happening in there, which is like, oh, that's pretty neat. But being cool and neat is not always the main criteria. Although, what do I say? I get so many things based on how cool and neat they are. So I should probably...
Wait, hold on. You get so many what?
I just get so many things based on their aesthetic first, and their objective qualities second. So I should probably shut up about this.
I mean, what if you're right? You might just be right, no? You don't think so?
I mean, it's like, when I was buying my motorcycle, I could have gotten a motorcycle for $6,000 that is kind of mainstream conventional, like a Kawasaki or something like that. But did I do that? No, I went for like a fancy Italian bike that looks amazing, but costs like literally twice as much, just purely on the aesthetic. And it's like, it's actually slower, a little bit worse in performance, and it breaks more often, but god damn it, it looks good. So, it can be helped.
Well, I mean, don't we all? I believe like this is very common. Yes. Everyone does this at some point.
It's like the myth of rational person. It's like a rational person would have bought like best performing thing that is cheapest in its class. It's like, was I the most rational person? It's like, no, I went for the looks, and I don't necessarily regret it. That thing was amazing. It was a lot of fun, and it looked good. So you gotta, if you're doing something, you gotta look good doing it.
Well, fair point.
Yeah.
I agree with you. You have to look. What's the point of doing it if you don't look good doing it? Like, what's the point? You don't want to look miserable doing it.
Yeah, exactly. And if you do Rust for first 8 months, you're gonna be miserable. So beware.
I mean, I hope not, because I read a lot about it, and to be honest, I would like to probably find some time to look into it, because it's getting a lot of traction.
Yeah. Well, I mean, it's fairly straightforward to start. You download Cargo, you install a nightly build, you get the language server for your IDE or whatever you're using, and they have a really good language server. The compiler is not the fastest, but coming from web dev side of things, that's not really a concern considering how long stuff takes to compile on our end of things without even actually having to compile anything. It's just literally converting text to other text, which is just nuts.
Yeah. I mean, I'm in the market for a new, I want to do like a new mobile app. Just so I have an idea, but I'm in the market to decide what tools I'm going to use.
Well, I don't think you can use mobile, like I don't think you can use Rust for mobile apps.
So it's not cross-platform then?
It's cross-platform. It's just that I don't know. I might be wrong. I don't know enough about it, but it just feels like if you're building for Android, you have to target the Java VM that Android runs on. So you can use like Java or Kotlin or something or whatever they have for it. And you can have native modules integrated to it, but bulk of the stuff is going to be in that JVM runtime thing that they have. And for iOS, again, it's like you want to use like Swift or things. I don't know, maybe somebody wrote some bindings for it to access like all of the toolkits that you need to access. But I think for mobile, I'm not 100% sure. I could be wrong. I haven't looked at it at all. It's just a hunch.
Well, I mean, I'll check if it is possible. It would be nice because this will give me the opportunity to actually see what this whole hype is about, you know. But
I was gonna say, leave your angry comment about. Of course, you can do that with Rust in the comments down below.
Yeah, please. It'd be nice to know. If we can do things like that. Because I was curious. Like I imagine it. I hope it's cross-platform because if it's not, then what's this noise about? Because
oh no, it is definitely cross-platform. Like you can build binaries for Windows, Linux, Mac, what have you. It's just targeting a certain architecture and certain operating system doesn't necessarily mean that you can just run it literally everywhere. I don't know. In terms of cross-platform, I think a lot of languages these days are quote-unquote cross-platform. Nobody's really doing like bit banging for specific CPU architecture and that's completely unportable to anything else. Like we're a couple of layers of abstractions above that, so we don't have to do that anymore. It's just like if you're building a GUI app, you need some common toolkit that is not native or has some bindings to the native controls, but then they're probably going to look like ass because Mac uses one design language, Windows uses another, Linux uses another, so you still need to adapt it for every platform you're building on. So yeah.
I have I mean, I know that you did Ruby for some time, and I'm curious, like if you get to compare languages like so I'll give you 5 languages, right?
Okay.
I'll give you 5 languages. I made popular language. And I want to see how you will rate each one of them and based on your criteria for rating it.
Let's do it.
So number 1, Rust, of course. And number 2, how does it compare with Ruby, Python, and Java and JavaScript? So we have Rust,
Ruby, Python, JavaScript.
JavaScript.
Okay, so well, out of those all, okay, so first of all, Java, it's a compiled language that is targeting a runtime. So you need like a Java runtime environment to run. So that gives you a lot of portability because, the runtime exists on many platforms and you're guaranteed compatibility a lot of places. Rust is a compiled language that produces platform-specific binaries, so you actually have to compile it for different platforms. Python, Ruby, and JavaScript are interpreted. So again, You can run them on all sorts of platforms. I don't know if you can run Node.js on Android, for instance, but apart from mobile phones, which are a bit of a special case, you can pretty much run it most places. In terms of friendliness, Ruby is probably the most friendly, followed by, I would say, Java and JavaScript and Python would share the second spot for this, and then Java, and then Rust at the very end in terms of just friendliness in how the language is presented to you. You can read Ruby basically like English prose. If it's written well, Ruby reads just like plain English most of the time, you know. In terms of its versatility, I guess that depends also. Like, I think you're gonna get the best performance out of Rust and Java, and you're probably gonna get the worst performance out of Ruby and Python, with JavaScript being somewhere in the middle. I guess Python, once they figure out their global lock things, which they have been trying for like last 10 years, you can probably get like more stuff out of Python. But just objectively, most benchmarks, Rust is very close to C, and C is like very close to assembly, and assembly is basically native CPU instructions. So like you can't really go faster than that. So like Rust is the best performance. Ruby is, it's the way that the language is done, because it's kind of this small talk derivative object-oriented, proper object-oriented language where things are passed by like signals from one object to another. It is quite slow compared to everything else. I guess all of them have a wide variety of external modules that you can attach to them. So if you don't find something in the language itself, pretty much all of them offer you some package that will help you solve that problem. What else? What else can we talk about? I guess you can use Java and Rust. It's easier to build GUI applications with them because Java has its own native JWT stuff, or whatever it might be these days. I don't know. I haven't done that in ages. But they used to have like a cross-platform GUI toolkit where you can build native apps for... Yeah. I just don't know if it's still JWT.
No, God, there is a, oh, no, not, it's part of it, but they have standard, like, anyway, moving on. I don't want to
moving on. Fair enough. And like in terms of building server applications, you can do it in all of them. So again, if you want expressiveness versus performance, that's kind of your choice to make. And of all of those, I guess my least favorite is probably Python. I was trying to write some Python code recently, and it's just like I was just stumbling over the most basic things. It's like, how do you print a thing to a screen with seeing all of its properties? It's like, with JavaScript, you just console log it and it like spits out the whole thing. You can see all the properties and all that stuff. Like same probably for like Ruby and things. For Java, there's ways. For Rust, I just don't know. Huh?
I'm noting all my questions because I don't want you to lose your train of thought.
Right.
I'm really enjoying how you're analyzing each one of them. So let's move on.
Okay.
You said you don't like Python's what was that?
It's just like the most basic things that I can know immediately what to do or what to look for. In Python, it's just like every time it's like, how do you do this in Python? How do you do that in Python? Like, I understand that Python has its own ways, and it's not one of my main languages. I just don't know. But I found it to be more frustrating to try to find the stuff I need compared to others. It's like, even like how to print an object to console in Python, it's like, oh my God, I have to do all this? It's like, seriously?
Really?
Yeah. Well, maybe there is some easy way that I couldn't find. But that's the thing too. If you're a newbie, like if I couldn't find it, the chances of you finding it are same or probably lower, because at least I have experience in other things to tailor my search. But if you don't have any experience, you're screwed. And I think that's a
Yeah,
big deal,
yeah, yeah, absolutely. And to be honest, I feel like you did really good with like the analysis. It's very informative, to be honest. Just I just wanted to ask you about like the Ruby, for example.
Yeah.
I know Ruby, and with I work with Ruby, so I'm curious about how you said because it is very, of course, everybody knows like everything is an object in Ruby. Like
Mm-hmm.
literally everything is an object.
Yep.
And but I don't know if this is when you said it's slow because of this, like because of the whole like heavily OOP oriented way of working, and this makes it. I feel even Java is the same. Like Java is also heavily.
Right,
These
but
are all.
Java is compiled, so it's optimized for the specific intermediate language for JVM, which is like if you look at the intermediate language for Java, it's basically like assembly. It's just specifically to target the JVM. So they can optimize a lot of it away. And I said that Ruby is it's OOP based, but it's like small talk proper OOP where you do a lot of stuff by message passing. And so, and again, I haven't used Ruby in quite a while. They could have improved it quite a bit since then, but just back when I was using it, it was like, yeah, if you want to build your stack in Ruby, provision 30% more on your servers to get the same performance. So like with other language, you can get more performance with fewer number of servers running it. It just needs bigger boxes. So it's like you pay more for that. You get all this user friendliness and you get like Rails and all these wonderful libraries that just makes development so fast. But you do pay for it too. So it's not free.
Wow. Okay. I didn't know this, but I guess I'm I'm curious about it. I'm gonna look into it, because I didn't know this. And also for Python, I feel like Python prides itself in like one of the best documented programming languages in the ecosystem because they seem to have the in the community. One of the first thing any Python fan will say is like, oh, we have the best documentation or something like this. And I find that should make it easier to use. And I was curious about when you said you could have print out an object in Python. I think it's if I'm not wrong, is it puts or printf or something like this that you use to to print it out?
So
I'm not.
yeah, I don't know.
Mhm.
It was I don't even remember what I was doing with it. I think I had some plugin that I was debugging for something that was, oh yeah, right, I remember. I was trying to hook up Let's Encrypt validator to do the work for my DNS provider because I needed to validate like a wildcard certificate. And it was just not doing the thing. It was giving me all these cryptic errors, and I was trying to kind of, you know, if that was some other excuse me, some other interpreted language, I would just go in and put a bunch of console logs in there to see what the heck was
Mhm.
going on. And with the Python, I was trying to figure out like this collection of parameters. It was supposed to read some configuration from the file, and it felt like some of these parameters like weren't getting where they were supposed to go. And I was just trying to print that configuration object at various stages of execution, and it would just say list of stuff without any mention of what's actually in there. And it's just like, oh my god, this is ridiculous. So I think I abandoned the whole thing, and I was like,
Okay.
screw it, I'll just renew it manually once every 3 months,
Yeah.
whatever.
Yeah. So maybe in that case, it's not actually like printing the
Yeah,
stuff that was the
yeah.
problem. It might just be like a computation somewhere in the code, or like.
Right, but that's the thing too. It was not. Um, I've done it before in other languages with more success,
Okay.
And it was not something that I would have just like started to sit down and learn Python over. It's like, can I solve it in the next 45 minutes? No. Okay, screw that then. Whatever.
Yeah. Yeah. Fair enough. Fair enough. And also you you mentioned that something about Rust.
Yeah.
It was but I feel like we've I feel like we've talked a lot about Rust today, but it was just
Yeah.
that you mentioned that it was interpreted. Did you say it's
No.
interpreted?
Rust is compiled. Rust is definitely
Compiled.
compiled.
What
Yes.
does it
Yes.
mean to be, I mean, for everyone listening, what
Hmm.
does it mean to be compiled and to be
Hmm.
interpreted?
Yeah. Fair
What does
enough.
that mean?
Good question. So compiled languages, the product from compiler is a file that contains direct machine code. So it has instructions for the processor, for the hardware parts. And I think these days a lot of it links out to the functionality from the operating system. But your program will tell the processors what functions to run and how to interface to the rest of the system. So it's native code. It's executing, well, broadly speaking, it's executing directly on a hardware. I mean, obviously, these days we have operating systems that will try to govern and abstract some parts of it, but for most part, it's true. Like, you can write a Rust program that targets a physical CPU without any operating system. Like, you can probably, I don't know about, I was gonna say, like, maybe you can build something that will boot on Raspberry Pi, but I don't know. Raspberry Pi is somewhat complicated, but like, if you have some sort of microcontroller that doesn't have any operating system because there's no room, you can probably write Rust code, compile it for that processor, and it will run on that microcontroller directly. Interpreted languages, so Java, okay, Java is sort of a middle part because it is compiled. It's just not compiled for the target's machine's CPU architecture. It's compiled for the Java runtime. And the Java runtime sits in between. So you tell Java runtime the instructions, and Java runtime invokes those on the hardware. So there's like a little bit of layer in between, which gives you things
Mhm.
like portability, because you can have runtimes for all the different operating systems, but as long as they expose the exact same interface for your program, you don't care. Like, you don't care that you're running on Intel versus Mac versus RISC versus ARM or what have you, right? Because the JVM, the Java Virtual Machine, is going to be the one translating those things. And they can optimize it quite heavily. So it's not as performant as direct machine execution, but it's pretty close. And then interpreted language is, a lot of them don't really transform the code into any other, like the code that you see is going to be executed by the interpreter. So the interpreter will read your code line by line and execute it without converting it to any kind of machine code representation first. I mean, there's a lot of modern techniques that help speed it up. So there's things like JIT, like just-in-time compilation, where your runtime is smart enough to detect certain patterns and optimize them sort of behind the scenes. So it can like kind of generate machine code dynamically as your program is executing. So if it finds like, oh, there's this function that does this loop, and it always does this loop, and it's always doing the same thing with the data that you pass to the loop, it's going to JIT it into a machine code, so it's going to run super fast. And if your program hits that loop thousands of times, first couple of times it's going to be slow because it's still going to be interpreted, but then it gets JITted away, and then boom, it's like super fast. There's a guy, I don't think he does that anymore. He was doing a lot of talks on V8, which is the JavaScript engine for Chrome and also basis of Node. He was talking a lot about optimizations in JIT and like all of the different things that it tries to do to speed things up. So you can probably look. I'll try to drop some links once the episode's out to his talks. It's quite interesting. All of the magic that goes into it. And Mozilla with their engine, they are doing a lot of stuff too. Like I remember there was a period of time where like Firefox was considerably slow compared to Chrome. And then with one release, it was just like super fast because they changed their internals for how their JavaScript runs, and it gotten like very, very fast. So it's kind of cool because, with compilers, a friend of mine, he used to work at Intel optimizing. Intel has their own C compiler, or maybe a C++ compiler. I don't know the details. But basically, customers would come to them and say, hey, we have this C code and it's generating this assembly code for the Intel processor that is suboptimal. So can you please teach the compiler to recognize this pattern and emit more optimized code for the target CPU? So he was working for the compiler division at Intel, and they were doing this. It's like corporate customers say, we have this optimized C code, but it's not producing the best assembly for the processor. Can you please make the compiler produce better assembly for it? And so it's kind of interesting that you can have exactly the same source code, and through the iteration of compiler design or interpreter implementation, you can actually make it faster as time goes by without actually having to change the source. Obviously, there's a limit to it, but it's still neat. And so that's why sometimes when I write code, I think this maybe is not the most optimized, but it is the most readable. And eventually, hopefully, fingers crossed, the compiler will reach, or the interpreter will reach such a stage of optimization that it actually is not going to be a problem anymore. And they keep making these changes to compilers and interpreters that make them faster without us having to do much on the source code side. So that's kind of cool. Yeah. Sorry, it ended up going a little bit in the weeds.
Yeah. But I have some questions to help with that. So JavaScript, according to this analysis now, will be compiled or interpreted.
So it's interpreted with heavy optimizations and just-in-time compilation by the runtime. So depending on what runtime you use to run it, like let's say if you run it on Node, it's going to have access to all of the V8's optimizations. But if you run it on Bun, because they're using a different JavaScript engine, it might perform better in some cases, but worse in others because their respective runtimes targeted different things for optimization. But it's transparent to you. As a programmer and as a user, you rarely have to really concern yourself about these things. And the funny thing is like, there are things you can do in JavaScript to completely destroy the jitting potential, and you can accidentally make your code unjittable, so it'll run crappy every time. But it's a bit more esoteric, I think, for the beginner level.
Yeah, I mean, I think so. But the reason why I'm asking you this is because I know that different, I don't know, maybe vanilla JavaScript might have a specific identity, like maybe interpreted or compiled, but like you said. But the reason why I'm asking you about this specifically is because I think in different frameworks of JavaScript, they sometimes configured with different types of compilation or like, for example, I know in Angular, you can have AOT.
Yeah. Ahead of time.
So
yeah.
Ahead of time
compilation compiler. Yeah.
So it's different from just in time. So like, and I had to look into it a little bit. I think this week actually, because one time someone asked me about the problem they had in their code. It was about using a private method in a template.
Mm-hmm.
So you declare your private method in an Angular, I don't know, like, our Angular ecosystem, right? Like you
roughly, yeah.
Yeah, you have your TypeScript class file, and then you have the template file, and
Mm-hmm.
then the test, and then whatever the rest. And he had defined the private method in the TypeScript class, but it wasn't accessible in the template file. And although usually, I've seen this happen a lot of times, like people do this and get away with it, like it doesn't complain.
Yeah.
But he was unable to compile his code because the compiler kept telling him like, oh, it's a private method and it's not accessible within the template class. And then I had to look into it, and then I realized that it was a thing with the AOT compiler,
Mm-hmm.
and that actually, I think it converts the templates file into a JavaScript file, and so it's like you are accessing a method or a property based on its accessibility criteria in the TS file. So if it's private, then you cannot save. Like it's only accessible within that file.
Yes.
So I learned about this, and then it got me thinking right now when we're talking that I think I don't know much about how it is in React. If React uses just in time or also just in time and AOT, or like maybe there are other ways. But I
Right.
think
Right.
in different JavaScript environments, it's possible to have different types of
Yeah.
compilers.
Yeah.
I'm
I
not
I think
sure.
I think we're kind of mixing the levels of abstractions. And speaking of that, I just remembered a very, well, not very, but somewhat inappropriate joke. It's like C++ is the only language where you can allow your friends to touch your privates.
Yeah, I mean,
Because
yeah,
there's like
Yeah, true.
friend classes in C++ that can
Hmm.
actually access private methods, but you know,
I don't know if they still
it,
have this now. Is it still there? I don't know.
probably. I mean, it's part of core design. But I think we're mixing layers of abstraction here because so technically speaking, compilation is conversion of source code into machine code. And none of
Mhm.
that is happening in the JavaScript world. So JIT, just-in-time compilation, it happens within the engine executing it. So by the time React and Angular and whatever, what have you, did its work, you have your final JavaScript bundle that's getting executed. Parts of that code could get JIT compiled into machine code uh, when the application is running. Broadly speaking, whenever we say, oh, we need to compile a React app or we need to compile our Angular app, the modern term is transpiling because we're converting one text file into another text file, or we convert one JavaScript flavor into another JavaScript flavor. It's like CoffeeScript. It's just different syntax, but it gets converted into JavaScript, and JavaScript, it's actually what's getting executed on the interpreter, like Node. So JIT doesn't come until way later. JIT only comes during execution. And so with Angular AOT, again, they transform your template into some JavaScript code, but it is basically, it's Angular itself. Like JavaScript has nothing to do with it, you know? So it's not compilation, strictly speaking. It's more of like pre-processing in a sense. And even, I mean, like the TypeScript compiler. Again, it converts TypeScript text into JavaScript text. There's no machine code involved. And it's doing its checks, and it mostly strips away things and polyfills some other things. But it's text-to-text translation. So by the time it gets to JIT, it is just still JavaScript text. Just not the one that you wrote, but rather what the compiler produced based on the code you wrote. It's kind of a very technical
No, I
pedantry.
mean, I understand it from my own view.
Mm-hmm.
It's just I'm just trying to put it into the movie that I'm thinking about right now, because I think it seems like the just in time is like, so I know that machine at the end of the day, like compilers, really the job of a compiler is to convert the code that you have into the machine language. So at the end of the day, we're looking to convert the methods, functions, and classes and whatever language you have written into the machine language, which will be the ones and zeros, like the literally like the codes, the machines
Yes.
language itself. So it seems like from the way you explain it, and which, like I said, I think you would know more about this than I do, because I think that the just-in-time sounds like the gatekeeper. So like when you do everything, even after it has been compiled by AOT, you still have to go through just-in-time.
Yes.
And for me, it feels like just-in-time is not, is just-in-time responsible for converting to the machine language, or just-in-time, and also what exactly is just-in-time when we compare like to other programming languages. So if I write my code in Ruby, for example, and I'm converting I need a compiler for this, and does it still go through just-in-time to get to the machine language? But just-in-time is only in JavaScript ecosystem.
No. Just-in-time is a broad concept. You can apply it to any interpreted language. So like the idea of just-in-time is, let's say you have a function add that takes parameters a, b, and it just literally returns a plus b. It's a function, right? And if you're running an interpreter, you could run all of the different things that the interpreter does to, go through its decision process and figure out, or just-in-time will look at it and say, we can replace this with an assembly add instruction to the CPU directly that just it's like much smaller amount of code. It's a very trivial example. It's very contrived, but it can obviously optimize much bigger pieces. Like it can do loops. So instead of having to do loops through the runtime where it actually has to like go through all of the machinery, it's like, I'm going to just convert this piece of code into machine code. And whenever I get to that point in the interpreted program, I'm just going to delegate it to the machine code that I've just produced and have in my memory, right? And so that is just in time. It analyzes the code as it's executing and it finds potential for optimizing. And then it produces the machine representation for that same code that can actually run on your target architecture directly without having to go through the interpreter. And it just short circuits it to run through the native code as opposed to interpreted code, where you actually read your JavaScript text file and execute instructions as they go along. So like if you turn off just-in-time, your code will still run, it'll just be slower. So just-in-time is a performance optimization strategy, and it does not apply for everything, but for some things it does, and for some things it makes a lot of difference. Performance-wise.
Yeah. This is how I understood just-in-time, So that's why I was confused, because like just-in-time started to sound like a compiler.
It is a compiler in a sense. It's just you never get to touch it because it's embedded inside the interpreter at runtime. Like the thing is, like if you worked with Python, you know that it creates this PYC files. Like every time you run your Python code, it litters your stuff with PYC file. So it's some sort of intermediary representation for the Python runtime, which again, it's kind of not exactly machine code. It's kind of like bytecode. But for JavaScript, it doesn't do that. So I guess we could have made something where like you run your application, it like generates this DLL file with actual machine code that it can defer to next time. But if you stop your program and you rerun it, the JIT has to do the work again to analyze it as it's running and produce the machine code and optimize it and things like that. So for some, if you only call a function once, it's never going to get JITted because the compiler haven't had the analyzer in the runtime haven't had the opportunity to say, oh, you know what, we can actually JIT this. But if it runs 10,000 times and it's simple enough, the JIT will be like, replace you with machine code.
Well, that's really nice to know. I'm good. It's a very good way to get into topics like this because, like you said, like you might go through your entire career without having to learn
Hmm.
any part of this, and
Yeah.
nobody's gonna question you. But it's fun to talk about and to look into,
Hmm.
especially um like the issue arose in the past week when I had to look at this to help in the situation. But yeah, it's really nice. I'm curious about it. I'm gonna look more into it as well, and maybe I'm gonna have more questions for you. So
Yeah, yeah. Google that guy. His name is Vyacheslav Egorov, and he does these or he used to. I think he switched to Dartlang or some other
Mhm.
language. He doesn't really do V8 development anymore. But he had a bunch of lectures. It was kind of crazy, like the amount of code. Like the V8 actually rewrites a whole bunch of your code and it eliminates dead code. Like, and if you have something like if you have a loop that does nothing in your code, V8 will actually just remove it entirely. So it does a lot of like it shifts a bunch of things around and like inline certain things. It transforms your code into something else entirely so that it can run fast. And you don't know necessarily that it happens, but it does, and it's really interesting to kind of like peel the curtain a little bit to see what it's actually doing.
yeah, and from my own point of view, I think like sometimes what exactly is referred to as the compiler
Mm-hmm.
is might be a bit it may not be very obvious to a lot of because there's like you said there's a lot of abstractions and like all these things. For example, I was just telling you about the AOT in Angular, and you mentioned the JIT,
Mm-hmm.
and I think all these abstractions they form part of the concept of compilation. But at the end of the day, I am of the opinion, but I don't know if I can say much about it right now because I'm not sure if I remember completely. But I know there were a lot of information I got about this, like in my in school about like compilers and like stuff like this. So I know there should be a particular part of it that makes those decisions, like the ones that actually converts to at what point do you get to the machine
Mm-hmm.
level of like interpretation. So I think most of these things just try to put some layers to make your code run faster or like to make your code improve performance. But I don't think they are exactly the compiler. They are not responsible for changing the code into machine language. I don't know. I think they just improve they're like, it seems to me like they're just like tools to improve the code for the machine language. So like maybe it filters in a way, like somehow. But I don't know if they are responsible for converting the codes into the machine language itself. I don't know, but I know there should be some layer there that is actually the compiler itself, like the ones somewhere around it. I don't know. So
Yeah.
yeah, this is something I would probably look into more and prepare my questions
Yeah,
for
yeah.
you.
Usually, like if you talk about compilers, you have to
Mhm.
start delving deep into, architecture, the underlying architecture, how the CPU works, how memory works, uh, and it's much low level compared to the day-to-day things. And that's why I guess if you choose some languages, kind of looping back to the very, very first question, if you choose some languages for your journey, it may be so that you never actually get exposed to any of these concepts for a really long time. That they actually exist, right?
True.
Like you can write JavaScript for years and never concern yourself about memory or CPUs or
For
bus
sure.
widths or interrupts or any of that, any stuff like that, and
Yeah.
just be completely blissfully ignorant. Um, and I don't know,
Yeah.
but it's still
Yeah.
there. It's still there, and you could still trip over it. And understanding it in detail makes you better at what you do. So it's worthwhile to know.
Yeah, for sure. Like the more you know about the environment and the ecosystem,
The
it's the better
more
your
you know.
decisions will be. It's the better your decisions will be in terms of like your quality of code yourself and all. So yeah, for sure, for sure. Anyway, thank you, Vasily. Thank you for your time. Uh, it's really nice. I guess we'll do this again next week, right?
We'll do this again next week. Thank you very much, Mo. Great questions. I
Yeah.
had a lot of fun going over them. And for all of you that are still watching, still with us, thank you very much for being here. Please, comment on the things you find interesting or questionable, and we'd be happy to chat with you in Telegram or Discord. Thank you and have a great day. Bye.